Welcome to our lecture online, and now let's talk about scientific notation. Yes, in astronomy we deal with very big numbers and sometimes with very tiny numbers as well. And we need to be able to write those in scientific notation, otherwise we'd be writing a lot of zeros. So for example, let's say the distance between the Earth and the Sun is 93 million miles, and it would be easier if we could write that in a more compact way. And so what we do is we write it as such. We write it as 9.3 times 10 to the, and now we need some exponent up there. It's always in terms of a number times 10 to some exponent. And so what we do here is we count the number of places, decimal places, that we go from the point between 9 and 3 to the end of the number. So we start from here, we see 1, 2, 3, 4, 5, 6, 7. So we write 10 to the 7th. 10 to the 7 is 10 million, and 10 million times 9.3 is 93 million. And that's how we write that. So this, of course, would be miles. How about the distance light travels in 1 year? It's about 6 trillion miles, and this is how we write it, 6 with 12 zeros. How do we write that in scientific notation? We write it as 6.0 times 10 to some exponent, and again, we count the number of zeros past the 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it becomes 6 times 10 to the 12th miles. And so that's how we write things in a more compact form. A good rule of thumb to use is whenever we see 10 to the 3rd, well, that would be equal to 1,000. If we see 10 to the 6th, that's equal to 1,000,000. If we see 10 to the 9th, that's equal to 1,000,000,000. And 10 to the 12th is equal to 1,000,000,000,000. So that way we can, in our mind, in our brain, we can very easily go from one to another. For example, if I see 10 to the 10th, I can think of this as that's equal to 10 to the 1st times 10 to the 9th. Because when you add exponents, I add it back to what we started with, 10 to the 10th. And remember, 10 to the 9th, we know that as billion, and 10 to the 1st power, that's simply 10 to the 1st power, which is equal to 10. So this is therefore equal to 10 billion. And what about the speed of light in terms of meters per second? It's 3 times 10 to the 8 meters per second. Well, how do we think about that number? Well, think about it this way. This is equal to 3 multiplied times 10 to the 2nd multiplied times 10 to the 6th. Again, when I add the two exponents, 2 plus 6 gives me 8 again. And then you can think of 10 to the 6th. Oh, I don't know what that is. That is equal to millions. And 10 to the 2nd, that's 10 times 10, which is 100. So this is basically 3 times 100 times a million. And of course, 3 times 100 is 300, so that's 300 million. And that's kind of the way you want to look at numbers in scientific notation. In astronomy, you look at this and go, okay, 10 to the 6th is million, 10 to the 8, that's 10 to the 2 more, 10 to the 2 is 100, 100 times 3 is 300, 300 million. And so that's kind of the way you want to think about it. Otherwise, you see those big scientific numbers, and you go, well, that doesn't mean a lot to me. So it's always nice to be able to simplify things like this in terms of thousand. Oh, and I'm missing a D, and there we go, thousand, million, billion, trillion, 10 to the 3rd, 10 to the 6th, 10 to the 9th, 10 to 12th, and that helps us look at numbers in astronomy in a more familiar way. And so that's really all we need to know about scientific notation. Maybe one more thing I may want to measure. Let's say I want to show the diameter of an atom. Well, the diameter of an atom is approximately 0.00000000001. Well, how do you write that in scientific notation? Well, now we talk about a very small number, which means we're going to need a negative exponent. So we could write this as 1 times 10 to the, and now of course we need to know how many decimal places, so we go from there all the way to the right of the 1. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But since it's a very small number, we write minus 10. So that would be 1 times 10 to the minus 10, and that would be in terms of meters, if we want to put units on that. So that would be a typical diameter of an atom. So in astronomy, when we talk about large things, we use positive exponents. When we talk about small things like the size of grains of sand and atoms and things like that, we talk about very small numbers like that. And scientific notation definitely helps us compact that. Otherwise, like I said, we'd be writing lots of zeros all the time. That's how we do that.